Take a look at this symbol and the letter X. In this situation, we are going to say that the letter X represents a number or an expression. But right now we don't have a number or an expression. But anyways, in math we call that symbol a radical, and the number or expression located inside the radical, we call that the radicand. So we have a radical sign that has the letter X, in which X for now represents the radicand. The radicand is valueless for now. So X represents a value. The square root of 81 is 9. Why is that? Well, because 9 times 9 equals 81. 9 times 9 equals 81. So the square root of 81 is 9. Instead of writing 9 times 9, we write it in a more standard form, like this. Nine squared. 9 squared. Oh, and by the way, we could have also solved for the square root of 81 by multiplying -9 times -9, in which you will still get positive 81. So the square root of 81 is 9 and -9. But 9, we say, we call it the principal square root because it is positive. As a matter of fact, the rule states that the principal square root can only be positive or 0. And another rule states that if x is an integer and a is a positive real number such that a is equal to x squared, then x is the square root of a. And a is a perfect square. In other words, 81 equals 9 squared. So let's get our feet wet. So we have in the first slot negative square root 81. Don't be alarmed by the negative sign. The same procedures, the same method will still take place. The only thing is we just have a negative sign out there on the end. So how about we do this? We'll keep that negative sign over here for now. So we know that the square root of 81 is 9. Don't forget to bring down that negative sign. And there you have it. 10 times 10. That equals 100, right? So the square root of 100 is 10. 0. 0 squared is equal to 0. So the square root of 0 is 0. So we have here the square root over a fraction, 49 over 81. So here's how we can do this. Since the square root is covering that whole fraction, how about we apply a square root to the numerator and a square root to the denominator. 7 times 7 equals 49, right? So the square root of 49 is equal to 7. 9 times 9 equals 81. So the square root of 81 equals 9. Same method. Let's go ahead, since the whole square root is covering that fraction, let's apply a square root to the numerator and the square root to the denominator. 5 times 5 equals 25, so the square root of 25 equals 5. 6 times 6 equals 36, so the square root of 36 is 6. So take a look at the bottom. These here are rational numbers. As you can see, there's nothing that we can multiply that's squared that we'll get an answer. So we can only get an approximation of the square of the roots. We can find the approximation of these irrationals with a calculator. So let me pull out my calculator. So square root 3 equals 1.732055. We'll just leave it right there. The number continues. And the square root of 7 will equals 2.6457, and so on. So what I'm gonna do, I'm gonna end it right here, but stay tuned, and we are going to be getting into the order of operations. Thank you.